Okay, this is the consolidation and storage of memory by Alon Mirochnik. I've selected topic 1, which is to provide justification for any scientific theory that explains where and how memories are stored in the brain. Memory is important because it makes us who we are. It guides how we act, and it governs our continual experience of life. In this presentation, I aim to outline some of the theories and models which explain how memory is consolidated and stored in the brain. More specifically, that memory must go through an information processing system, that levels of processing must occur in order for long-term memory storage, and I will talk about the main brain structure involved in memory. Okay, so the information processing model of memory, which was source 1, describes memory as a 3-stage process which involves active engagement from the individual. There are 3 stores: sensory memory, short-term/working memory, and long-term memory. So each of these interrelated stages are different types of storage systems with different capacities and durations. Capacity refers to the amount of items which it can hold in the memory, and duration is the amount of time which it can hold that information. So the first store is sensory memory, and it is defined as a type of memory that holds large amounts of incoming information very briefly, but long enough to connect one impression to the next. It involves sensory registers, which are like sensory bins, which hold information and hold that sensory information. And each sense has its own sensory register. For example, sight has iconic memory and sound has echoic memory. So if selective attention occurs and one focuses on the stimuli in the environment, the next stage of memory occurs. The next stage is short-term memory, and it is defined as the maintenance component of working memory, which holds unrehearsed information for a limited time. The storage duration can last up to 18 seconds, and its capacity is generally 7 plus or minus 2 items. And to increase the capacity of short-term memory, chunking can be used, which involves grouping bits of information to make it into one. There is acoustic and visual encoding into short-term memory. And if the information is rehearsed in working memory, it can be stored indefinitely, and that is covered in the next source. So once it is rehearsed, it goes to long-term memory, which is defined as a relatively long-lasting stage of memory whose capacity to store new information is believed to be unlimited. And it is, of course, the final stage of the information processing memory. In fact, most people even view long-term memory as just memory. Okay, so the second theory is the levels of processing model of memory. And it refers to the depth of processing that information undergoes in the brain. There are 2 main types of rehearsal: maintenance and elaborative. Maintenance is repeated repetition of information, which makes it more likely to be stored. And elaborative is making sense of the information, which is generally a better way to rehearse information. So there is a study conducted by Ezra Mungan, Zera F. Pay-Nir-Sioglu, and Andrea R. Helpin. And it involves remember and know responses in melody recognition. Remember recognition refers to a subjective state of being able to retrieve the moment when the item was being encountered, and know recognition is subjective state of retrieving information without remembering detailed information. And of course, they say that it's modulated by item familiarity. So in experiment 1, there are 2 conceptual and 2 perceptual orienting tasks while listening to familiar tunes. So the tasks were judging mood, continuing tune, tracing pitch contour, and counting long notes. The first 2 of those are conceptual and the second 2 are perceptual. Experiment 2, the participants judged mood or counted long notes of tune. Judging mood is conceptual and counting long notes of tune is, of course, perceptual. And they did it with high or low familiarity, meaning that the participants either knew the tune or didn't. So the findings of this study were that remember type recognition sensitivity was consistently more effective than the know recognition. And experiment 1 found that the mood task led to a high rate of remember responses. And that experiment 2 found that regardless of the familiarity of the tune, the mood task was effective for remember responses. Now, why is that? That is because mood tasks are considered to be more distinctive. And they found that an item's distinctiveness is found to have the strongest effect on remember responses, which is a deeper level of processing. So due to the familiar tune's natural distinctiveness, remember responses are more likely. And the perceptual tasks were less likely to produce distinctive processing. The overall conclusion was that recollection-based recognition relies on the distinctiveness of the task rather than its conceptual or perceptual nature. Okay, source 3 explains the brain structure involved in memory, which is, of course, the hippocampus. And it looks like an elongated structure buried deep within the medial temporal lobe. It is said to look like a seahorse, which is actually where the name is derived from, which is genus hippocampus. It involves long-term potentiation, place cells, head direction cells, and grid cells. And it, of course, undergoes a spatiotemporal framework. Its critical function is to store and retrieve memories, mainly episodic. So it highlights a case study of HM, which was a man who suffered from intractable epilepsy. He was unable to form new explicit memories due to his surgical removal of the hippocampus. And that's what led to the main research on hippocampus functioning. So declarative memories are what the hippocampus is mainly used for. So it is divided into two parts, episodic and semantic. Episodic can be defined as a memory's event from individuals' past, and semantic is one's storage of general knowledge and facts. So this article also talks about the animal studies which prove the hippocampus is functioning, such as the Morris water maze, which is an experiment done with two groups, one group of rats which have a properly functioning hippocampus and one that doesn't. So these rats were placed in a pool of opaque water and had to find this hidden escape platform. So the rats without functioning hippocampus were actually unable to find the platform after many goes. But the ones with functioning hippocampus, after the first couple of goes, they started figuring out where it would be. It also talks about place cells, which is the neural activity in the hippocampus, which is mainly responsible for the spatiotemporal framework. And it gives you a cognitive map of the environment. Now, evaluating this evidence, in source 1, which was the textbook, it was a reliable resource because it's from Monash University. It explains the theory in depth and defines all key terms, and it refers to previous studies to back up the information. However, there was no actual study or experiment done. It doesn't actually list any limitations, and it's pretty broad information. In source 2, the levels of processing model of memory, which was in the American Journal of Psychology, it's a peer-reviewed journal, which automatically makes it reliable. It refers to many previous studies. It outlines the entire study and discusses the results thoroughly, provides ways to improve the study, and they attempted to minimize extraneous variables by random shuffling in the item recognition list. However, they use convenience sampling, which makes the results less generalizable, and it's quite a small sample size. There was only 32 participants. In source 3, which was brain structures involved in memory from Current Biology, again, peer-reviewed journal, makes it reliable, provides a well-known case study. There are animal studies to prove its validity, and there was even application to humans, and it talked about the biological level. However, there was no experiment of its own, and it was way more biologically based than psychologically. In conclusion, I've found that memory is a complex 3-stage process that involves active engagement, and the way in which one engages with the information can predict the strength of the memory. And of course, the hippocampus plays a large role in the formation of the memories. However, there's still lots to